A lot of the things in radiology have multiple meanings, and quality is one of those things. So we have radiographic quality, and that is the resulting image and how it looks. But we also have beam quality. And beam quality has more to do with energy of the X-ray beam. An X-ray beam that doesn't penetrate is of low energy, and therefore it is of low quality. So KVP is how we control quality of the X-ray beam, but it's not the best measure of X-ray beam quality. It is a measure of beam quality, but it's not the best measure. Half value layer is a much better measure. Half value layer is the amount of any absorber, but usually aluminum, that it takes to cut the intensity of the X-ray beam in half. So if you have two X-ray beams, both with the same KVP, both shoot with the same mass value, and if you put 1 millimeter of aluminum into the X-ray beam, and after the aluminum, what you have is half of the original intensity, what you have is a half value layer. So let's say you generate an X-ray beam with 70 kVp and 25 mass. And just for hypothetical, that 25 mass generates maybe 100 MR of exposure. If you put 1 millimeter of aluminum just below the tube housing and you shoot through that aluminum, and that aluminum cuts it down to 50 MR of exposure with exactly the same technique, then what you have is a remnant beam with half of the original intensity. That would be a half value layer. If it took 2 layers of aluminum to cut it in half, then that would be, its half value layer would be 2 millimeters of aluminum. If it took 3 millimeters of aluminum to cut it down to 50, that would be the half value layer being 3 millimeters of aluminum. Now, if you had two X-ray beams with exactly the same technique and exactly the same output, so you got two different X-ray units in two different rooms, and both of them generate, if you generate a beam with 70 kVp at 25 mass, and they both have 100 MR of exposure at the collimator, and in one of the rooms you put a single millimeter of aluminum and it cuts it in half, you take that same millimeter of aluminum, put it in the other room, generate the same beam, and what you've got is not 50 but 75, then what that means is you've got a more penetrating beam in the second room. Penetration is your quality. So if you have a more penetrating beam, even though the KVP and the mass values are the same, what actually penetrated through were higher average energy X-ray photons. So in that way, half value layer is a better measure of quality than what KVP is. How you get to a higher half value layer is through a lot of different ways. If you remember talking about generator type in the first semester, whenever we moved from a single phase generator to a three-phase generator or high frequency generator, our potential never dropped to zero, which means that what we were left with was kind of like averaging out grades. If you eliminate the lowest grades, then what happens to your average is that it increases. Well, since we never dropped to zero with a three-phase generator or high frequency generator, we have a higher average beam energy with a three-phase and high frequency generator than what we do with a single phase. Also, as the tube ages, remember what we have is tanning. And tanning is laying down of more inherent filtration on the inside of the X-ray tube as the filament vaporizes. So every 6 months to a year, the physicist has to come in and make sure that the KVP and the mass that you set give you an accurate KVP and an accurate MR to MAS output. What that means is that for every mass that you generate, you should have a specific MR. But since we've got that added layer of filtration on the inside, naturally as the tube ages, your output's going to go down. So what the physicist has to do is he has to increase the output from that tube. But since it's going through more filtration and you know what the purpose for filtration is, and that is to increase the average beam energy, or really it's to remove low energy photons. And that, since it removes low energy photons, the average goes up. Again, kind of like averaging a test. You remove the low energy, and that the average increases. So as the tube ages, it gets more filtration on the inside of the tube. The output goes down. The physicist re-increases the output, but the X-ray tube, because of the filtration, the increased inherent filtration, those low energy photons don't make it out of the X-ray tube. So what you're left with is the same MR to MAS output, but the energy level of the photons that are coming out are higher. So with tube age and with any kind of filtration, what we get is removal of those low energy photons. We get adjustment of the output when they QA the tube every year, run quality control tests on the tube. And so we get the same MR to MAS output with higher average beam energy, and therefore we have a higher quality beam with more filtration, specifically more added filtration, or an increase in inherent filtration.